Hello everybody, welcome to another video on nodal analysis. In this video we'll be using the supernode again. Before we proceed to solving the question, do not forget to hit the like button and subscribe. Also hit the notification bell to get notified when I upload the next video. Thank you. Let's proceed to finding the node voltages in this circuit. So let's label the nodes: node 1, node 2, and node 3. Now the node voltage of node 1 is quite obvious because in between node 1 and the reference node, a voltage source is connected directly, and the value of the voltage source is 10 volts. So we know that node 1 is greater than the reference node by 10 volts. So V1 minus 0 equals 10 volts. That's V1 equals 10 volts. That was easy. Then we move on to node 2 and 3. Because node 2 and 3 are connected by a voltage source, they can be combined into a supernode. That is, they are combined by a voltage source alone. There is no resistor in between them, so we can combine them into a supernode. So we go ahead and combine them into a supernode. And before we write the supernode, the KCL equation at the supernode, we first have to write an equation that connects node 2 to node 3. Now we see that node 2 is higher in potential than by node 3 by 5 volts. It is higher than node 3 by 5 volts. So we say that V2 minus V3 equals 5, and we call that our first equation. Then we write the equation at the supernode. So we start at node 2. We write for this branch, that will be V2 minus V1 divided by 2. So at our supernode 2, 3, V2 minus V1 divided by 2, V2 minus V1 divided by 2. Then at this branch, we have V2 divided by 8. Then we skip this branch that connects the supernodes. Then we move over to node 3. That would be V3 minus 0 divided by 6. That's V3 divided by 6. Okay. Then we also write for this branch. That would be plus V3 minus V1 divided by 4, all equals 0, and we have written the equation at the supernode. Then the next thing we do is we simplify the expression. So in order to do that, we multiply through by 48. Multiplying through by 48, we have 24 V2 minus 24 V1 plus 6 V2 plus 8 V3 plus 12 V3 minus 12 V1 equals 0. Simplifying this further, we get that 30 V2 minus 36 V1 V3 plus 20 V3 equals 0. Okay, and we know that V1 is equals to 10, so we can say 30 V2 plus 20 V3 equals 360. I can call this our second equation. Then we can go ahead to solve these two equations simultaneously. By solving it simultaneously, we arrive at the value of V2 to be equals to 9.2 volts and the value of V3 to be equals to 4.2 volts. And then we have solved for our node voltages. Thank you for watching the video. Don't forget to like and subscribe.